So we see that we cannot use univariate data drift for predicting performance. Why is that? So basically, it comes from two or even three sides. First, the false positives are bound to happen and they are bound to happen quite often if we have enough features. Let's say that our model has 100 or 200 or 300 features. What will happen is that some of them will drift significantly, but the model will generally handle that well. So we're going to get a lot of false positives. We're going to get a lot of false signals that then a machine learning model either will learn to ignore or will falsely interpret as signal. The second reason is that the models are robust to change in data distribution, which means that even if we see actual meaningful change that's not just a statistical fluke, it still doesn't mean that it actually impacts performance in any way, because even if the data looks completely different, especially on features that are not very important, we don't expect to see a drift in performance or change in performance. Or if data drifts to regions that are equally easy to predict on as the data distribution that we mostly saw in the test set, we still don't expect to see a drop in performance. And then lastly, if we stick with univariate methods, then the drift in the relationship between features is not captured. And to illustrate that point, I have this visualization here. When we look at two features, and we see that if we look at it from the univariate standpoint, the univariate distributions are virtually the same. They're virtually identical. But if we look at the 2D plot, what we see is that the feature got actually rotated by 90 degrees. So there is insanely strong data drift. Most likely the features actually got swapped somewhere in the data engineering pipeline. But we see that univariate drift detection will actually not detect it. Of course, this is a fake example that still can happen in the real world because we saw features just getting swapped, the names of features getting swapped, but the actual features staying the same, which means that the algorithm will interpret it exactly as you can see here by rotating it. So this is something that can happen. Even a slightly contrived example, you can clearly imagine that there might be a very strong drift in the correlations or relationship between features, but we won't be able to catch it with just univariate drift detection methods.